Hello everyone, welcome back. I hope all are safe at home. So today we'll begin with the next topics in the same fifth module of gas turbine technology course. So today we will be discussing on first accelerated mission test. So when we say an engine testing, basically previously what used to happen was they used to test only for endurance, means suddenly the fuel throttling will be done or it will be varied as per the requirement, and based on that the amount of thrust produced or the amount of fuel consumed will vary, which decides the endurance of that particular engine. But that is not sufficient to test the components, because there are few components which are thermally loaded as well as mechanically loaded. So for that, those particular components of a gas turbine engine, they have started with a new testing, that is accelerated or acceleration mission test. So which is very similar to military qualification test, but in this they are going to suddenly change the throttling. The fuel supply throttle will be changed suddenly, and due to that whatever rise in temperature is going to take place, or in the second case if it is decelerating and suddenly the throttling lever is reduced, so the amount of fuel is reduced for the combustor, and due to that whatever variation or drop in the temperature is going to take place, due to that the thermal load acting on those hot components, specifically the turbine blades, due to the turbine inlet temperature, if it varies, then due to that the creep is going to act accordingly, and this creep phenomena decides the life of a component. So in acceleration mission test, the intention or the motive is to find the creep on hot components of an engine, not just endurance. Apart from that creep, yes, the endurance of the engine can also be determined. Now, the accelerated mission test includes the high power time, means for how long the engine or the hot components are exposed for high temperature. And second one is how many times the throttles are excurred, like how many times it is going to suddenly accelerated and decelerated in its complete flight envelope. And third one is what will be the rise in temperature and pressure due to this. Fourth one is if it is augmented engine, like thrust augmented engine, then how many times the light up for that augmentation is done. So for all these four parameters, this AMT accelerated mission test is used. Let's move on to the next one, that is high cycle fatigue characterization test. So it is an engine characterization test which decides or which will be helpful in certifying that particular engine. So in this particular test, the intention or the motive is to find the high cycle fatigue or the life of a fatigue life of that particular component. So in this, the engine components, the vibratory motion of those engine components are measured, and those will be used to determine what will be the fatigue life. So if the fatigue level is less than 60% of the Goodman's limit. So Goodman's limit, as we have discussed in the course structures, the Goodman's limit is very same as the equation what we have used, Goodman's and Soderberg. So in the Goodman equation, we are going to deduce different types of stresses. Now, the limit is set for that particular equation, or that particular limit is 60%. If it crosses that 60%, then the high cycle fatigue life will drop down, which means the life of the component will drop down. Whereas it is taken care that the limit what we are going to, the vibration limit what we are going to have in this particular test is less than 60% of Goodman. So this is helpful to characterize or to certify that particular engine. So this is about high cycle fatigue characterization test, which decides or which depends on the vibration levels of each components, and those vibration levels leads to some stresses, and those stresses has to be less than 60% of Goodman's limit to keep them for high cycle or high life cycle. Then structural integrity test. There are different structural integrity tests, so we'll discuss very few among them. So the first one is extensive test facility. So it is given in the notes, you can go through along. So in the extensive test facility, the rotating component disk are tested. So how well the structural integrity or the life of that particular disk is evaluated in extensive test facility. Whereas in cyclic spin test facility, it is not just mechanical load will be tested, it will be tested for mechanical load with the temperature variation. So this will help to find the low cycle fatigue life. The cyclic spin test will help to find low cycle fatigue life. Then torsional test facility. If you could remember the torsion test or the experiment on torsion you have done in mechanics of material lab. So where we will be using a twisting moment equations. So which will help to find the fatigue life. Similarly, this torsional test facility here is used to find the fatigue life of rotor shaft. Next one is dynamic foreign body impact test, where bird model is simulated and made to impact on certain part of an engine like a rotor blades, disc, casings, and once it impacts, what is the level of impact energy is deduced. So which will help us to find what will be the level of deformation in that particular material. So that is about dynamic foreign body impact test. Then there is next one, full scale power absorption test facility, where the performance and the endurance of the gearbox what we'll use for an engines are tested. How well it is going to perform. So it is very similar to water brake dynamometer. Next one is attitude testing. So attitude testing is nothing but in this particular test, the particular engine gearbox is designed and that particular design is tested because the aircraft is not necessarily should be maintaining the same attitude. It will be varying as per the requirement. So it will be maneuvering, and due to that, what will be the performance or how well the gearbox is going to function. For that, the attitude testing is done. Along with this, how much fuel is required, how much is the fuel flow rate for the different altitude, what will be the oil supply, how much will be the leakage due to these altitudes. So to measure these things, there are other tests as well which are given in the notes. So this is about structural integrity test. So if you have any doubts, please let me know. Thank you.